flooded coastlines, pitch-black nights, and an ice age far harsher than anything Earth has endured. This is what happens when we replace our familiar moon with the strange and dangerous moons scattered across the solar system. Spoiler alert, you're not making it through most of these timelines. Let us begin with a moon that looks peaceful until it destroys your cities in slow motion. Rhea, you're used to the moon's pale glow, gentle tides, and familiar craters. Now imagine looking up and seeing a gigantic icy marble, striped with fractures and shimmering like frosted glass. That's Saturn's moon, Rhea. Rhea is almost twice as reflective as our moon, and its surface is coated in bright ice. At night, Earth would glow with a faint icy blue hue. Romantic, maybe, but that's where the good news ends. Rhea has considerably more mass than our moon. Specifically, it's about 1.5 times more massive. Now, that might not sound like a huge difference, but in the delicate dance of orbital mechanics, it's catastrophic. The first thing you'd notice are the tides. Our current tides, governed by the moon, are predictable, creating a rise and fall of a few feet in most places. With Rhea in orbit, that gentle rhythm becomes a relentless assault. Tides would swell to be 1.5 times higher. Coastal cities like New York, Shanghai, and Miami would face constant, devastating floods. Seawalls would be useless. Entire neighborhoods would be swallowed by the ocean, not in a single cataclysm, but in a slow, grinding, daily deluge. Living near the coast would become impossible. Millions would be displaced, creating a refugee crisis on a global scale. But the chaos doesn't stop at the shoreline. Rhea's stronger gravitational pull would tug on Earth's crust itself. This increased stress on tectonic plates would trigger more frequent and powerful earthquakes and volcanic eruptions. The Ring of Fire would live up to its name like never before, spewing ash into the atmosphere and shaking cities to their foundations. It's a world teetering on the brink of geological collapse. So, while Rhea might look beautiful in the night sky, its presence would mean the slow-motion destruction of our civilization. Next up, a world of perpetual twilight and crushing gravity. Titan. Imagine stepping outside and seeing a hazy orange giant hanging in the sky. You can't see its surface, just a thick, smoggy atmosphere. This is Titan, Saturn's largest moon, and it's a monster. Titan is over twice as massive as our moon and significantly larger. Its gravitational pull on Earth would be immense. The tides would be more than double their current height, making Rhea's floods look like a minor inconvenience. Coastal cities wouldn't just be flooded, they'd be permanently submerged. We're talking about redrawing the maps of every continent on Earth. But the real showstopper with Titan is its atmosphere. It's thick, dense, and full of nitrogen and methane. From our perspective on Earth, Titan would block out a huge amount of sunlight. Days would become dim, murky affairs, like a perpetual overcast evening. This would have a devastating effect on plant life. Photosynthesis would plummet. Crops would fail on a global scale, leading to widespread famine. Our planet's entire food chain would collapse, starting from the very bottom. The reduction in sunlight would also cause global temperatures to drop dramatically. We'd be plunged into a new ice age, but one driven by a hazy orange orb in the sky. Glaciers would advance from the poles, consuming vast swaths of land. Earth would become a cold, dark, and hungry planet. Living on Titan's Earth would be a struggle for survival in a world that's slowly freezing and starving to death. Now, let's journey to a world of fire and brimstone. Say hello to your new moon. Io, Jupiter's innermost Galilean moon, is the most volcanically active body in the entire solar system. Visually, it would be a spectacle. Instead of a calm gray orb, our night sky would be dominated by a mottled yellow, orange, and black sphere, constantly belching plumes of sulfur and lava into space. It would be like having a front-row seat to a planetary-scale fireworks show every single night. But the beauty is deceptive. Io is slightly more massive than our moon, so the tides would be a bit higher, causing more coastal flooding, similar to what we saw with Rhea. But with an added, terrifying twist. Io is tidally locked and stretched by Jupiter's immense gravity, which is why it's so volcanically active. Placed in orbit around Earth, that internal heating might lessen, but its legacy of spewing material would continue. Io would trail a plume of sulfur dioxide and other volcanic gases. As Earth passes through this trail, these gases would rain down into our atmosphere. We'd experience constant, severe acid rain. This would poison our water supplies, kill forests, and corrode our buildings. The sky would often have a yellowish tint, and the air would smell faintly of rotten eggs. Furthermore, Io's volcanism ejects charged particles, creating a plasma torus around it. This would bombard Earth's magnetic field, leading to intense and unpredictable auroras visible across the globe, but also wreaking havoc on our satellites and power grids. Living under Io would mean living in a world slowly being poisoned from above. What if we went in the opposite direction? What if our new moon was tiny? Let's swap our moon for Phobos, one of Mars's two small, potato-shaped moons. Looking up, you'd barely see it. Phobos is incredibly small, only about 22 kilometers in diameter. It would appear as just a bright star, moving surprisingly fast across the sky. In fact, it would orbit the Earth several times a day. Because it's so tiny and has negligible mass compared to our moon, its gravitational effects would be practically non-existent. Tides would vanish. The oceans would become eerily calm. The familiar rise and fall of the sea would be gone, which might sound peaceful, but it would have huge consequences for coastal ecosystems that depend on tidal flows. But the biggest change would be at night. Our nights would become profoundly dark. Without the moon's reflected light, the darkness would be absolute, broken only by the pinpricks of starlight. The Milky Way would be visible and stunning, brilliant detail from almost anywhere on Earth, free from moonlight's glare. However, this darkness would also affect nocturnal animals. Many species have evolved to hunt, navigate, and reproduce based on the cycles of moonlight. Without it, their worlds would be thrown into chaos. But the most dramatic part of Phobos' story is its orbital decay. Phobos is slowly spiraling closer to Mars. Around Earth, it would do the same. Over thousands of years, it would get closer and closer, eventually reaching the Roche limit, the point where Earth's gravity would tear it apart. Phobos would disintegrate into a spectacular ring of rock and dust around our planet, turning Earth into a mini-Saturn. For a while, it would be beautiful, but eventually, that ring material would rain down, leading to a constant meteor shower, threatening life and anything we try to put into orbit. Finally, let's bring in the king of moons, Ganymede. This is Jupiter's largest moon, and it's bigger than the planet Mercury. Swapping our moon for Ganymede would be, without exaggeration, the end of the world as we know it. Ganymede is more than 25 times more massive than our moon. The moment it's placed in orbit, its gravity would unleash planetary chaos. The tides wouldn't just be high, they would be unimaginable tsunamis, hundreds of feet tall, that would scour the continents clean. No coastline would survive. The oceans would violently reshape the planet's surface in a matter of days. Simultaneously, the gravitational stress on Earth's crust would be apocalyptic. We're talking about global, continent-shattering earthquakes and volcanic eruptions on a scale never seen in human history. The planet's surface would crack open. The atmosphere would fill with so much ash and gas that it would block out the sun entirely, triggering an instant and deep ice age. But even that wouldn't be the end of it. The Earth and Ganymede would become a binary planet system. Their gravitational interactions would be unstable. They would tug on each other, deforming each other as shapes, and potentially flinging our new two-planet system into a completely different orbit around the sun, or perhaps into the sun itself. Life on Earth wouldn't stand a chance. It would be a spectacular, terrifying, and very, very short-lived experiment. It goes to show just how lucky we are. Our moon is the perfect size, at the perfect distance, to create a stable and life-sustaining environment. It's not too big, not too small, it's just right. So, next time you look up at that familiar, pale face in the night sky, give it a little nod of appreciation. It's more than just a pretty light, it's our silent guardian, the anchor that keeps our world stable and alive. Thanks for watching. If you enjoyed this cosmic journey, don't forget to like, subscribe, and hit the bell icon so you don't miss our next dive into the what-ifs of the universe. See you next time.